Hello everyone. Today we're going to finish lesson 19.1, day 4, which is on the topic of stretching, compressing, reflecting sine and cosine graphs, and we will be able to model with sine or cosine functions in real-world problems. So here we go. Example 1. We have some notes here that we need to remember. There's a new formula here too. Let's read this together. Sine and cosine functions can be used to model real-world phenomena, such as sound waves. Different sound creates different waves. One way to distinguish sound is by measuring frequency. Frequency is the number of cycles in a given unit of time, so it is the reciprocal of the period of a function. Here is the equation. Frequency equals 1 over period. Or you can rewrite it as F equals 1 over P for easier shorter. And then usually the measure of unit is hertz, is the standard measure of frequency, and represents 1 cycle per second. So in 1 second, how many times does this go? That's the frequency, right? And for example, the sound wave made by a tuning fork for middle A has a frequency of 440 hertz. This means that the wave repeats 440 times in 1 second. Wow, that is fast, right? As a tuning fork vibrates, it creates fluctuations in air pressure. The maximum change in air pressure, typically measured in Pascal, is the sound wave amplitude. So we already know what amplitude is, and so this is how you can use amplitude in real world situations, like depending on the fluctuation of the sound wave or the pitch that it makes, right? So we do get one equation out of this, so hopefully you guys will remember that equation. So whenever you're asked to find the frequency, you will use 1 over period, right? Let's take a look at example 1. Use a cosine function to graph a sound wave with a period of 0.010 second and an amplitude of 3 pascals. Note that the recording of the sound wave started when the wave was at its maximum height. So part A, find the frequency. What does the frequency represent? So once again, we should know that using the formula that we have earlier, frequency is equal to 1 over period. From the description, it looks like the period, it's already specified, is at 0.010. So if we actually use the formula and substitute the period, that's 1 over 0.010, which is, if you have that function 1 over x on your calculator, you can use that, or you can just literally take 1 divided by 0.010, and you should be able to get the answer of 100. And this unit is measured, remember, frequency is measured in hertz. So this is the number of curves the sound waves makes in 1 second. So in 1 second, the sound wave goes in 100 times, right? And that's what it means. Find the amplitude. That's the next thing. Find the amplitude, and then what does the amplitude represent? So remember here, they're giving you that the amplitude is 3. And so A is equal to 3. And the amplitude represents the maximum change in air pressure, because we are talking about air pressure here. So that's what it means. And C, find a period. And we already know, we said it earlier, period is 0.0. And what does the period represent? That means it represents the amount of time it takes for the sound wave to repeat. So from one wave to the next one, it takes 0.010 seconds, right? And part D, graph the function. So if we actually partition the period into 4 parts, we can go ahead and so partition, we'll be taking the period, which is 0.010, dividing by 4, which will give you 0.005. And that's why we're starting with 0.005, then adding 0.005 every time. So we get 0.01, 0.015, and then finally ending up 0.02. And that's what we have for each one of the intervals. Okay. And then, so if we I actually did not do my math right. So let me go ahead and do this on the calculator. I should just use the calculator. So 0.01 divided by 4. So these intervals should be going in 0.0025. Okay, and so then if we continue this, so we can sort of start like a little table here. So we have 0, then we have 0.0025, and then adding that same thing. So we're going to have 0.005, and then 0.0075, and then 0.01 finally at the ending point. So these points are just for reference for us. So let's mark the points, and then amplitude is going to be at 3. So it's going to be here, the maximum, and the minimum is -3. So we should have the point 0 at the maximum because we are following a cosine function, which means we're starting at the maximum. So at 0, it's going to be the maximum at 3. And then next one, we're going to come back to 0. So here. So I'm going to divide this into 2 parts. So that's 1 full period, and that's going to be the other 3. Okay, so over here, we're going to come back to 0. And then at the next one, it's going to go to the minimum, which is -3. So here are your points. So minimum right here. And then the next one is going to come back to 0. And then finally go back to the maximum. So come back to 0 here, and then maximum right here. So here is the actual graph. And that represents the cosine. So this is what the graph looks like. And that's the end of this problem dealing with real life situation in sound wave and actually air pressure. Sound wave and air pressure. Okay, so here we are. The next problem. A pendulum makes one back and forth swing every 1.5 seconds. And its horizontal displacement relative to its position at rest is measured in inches. So we got back and forth 1.5 seconds. Starting when the pendulum is 5 inches, the maximum. At the right of its position, use a cosine function. Specifically, they say cosine to graph over time. So once again, we are asked for part 1 to find the frequency. And what does that represent? So the frequency, again, here is found by the formula 1 over period. And we need to know what the period is. And it looks like period should be 1.5 seconds because it is repeating back and forth, right? So that's the period. So it's 1 over 1.5. When you divide that, you should get 0.7 hertz. So it is going not one full swing in 1 second. It's going 0.7 of 0.7 hertz, which means that's the number of time in 1 second. So it's not one full swing yet, not one full. So 0.7 of the way only in 1 second. B says find the amplitude. A is equal to, it is given the amplitude, which is 5 right here. So the vertical displacement, that's what it means. The amplitude, which is 5. And that is in inches. And this represents the maximum height. Okay, and then this is the number of times in second. 1 second. Find the period. So period is actually 1.5, like we said on top. And this is the time that it will take for 1 swing. Okay, that's what it means. And then it says graph the function using a cosine. So once again, for the cosine function, we start at the maximum, which is at 5, because it says that the maximum is going to be at 5. And then we come back and we need to take the period, which is 1.5, and divide that, use the partition. We divide it by 4. So we have 1.5 divided by 4. It is each one of those unit is 0.375. And then we come back to 0. And then we add 0.375 again. We get 0.75. We go to the minimum of -5. and we add again the 0. What did I say? 375. So you're adding 0.375 every single time. And then come back to 0, and finally we're at 1.5, which is 1 full period, right? At the maximum again at 5. So let's take a look at where these units are. So we start with 0, then we end at 1.5. So we're going to chop it half, half, half. So that's what we have. And then at 0 is going to be at the maximum, which is 5. Let me try another color. And then at 375 is going to be 0. At 0.75 is going to be at -5, way out here, down here. And then 1.25 is going to be back at 0, and then at the maximum is at 1.5. So this is what the full period looks like in a cosine model. And that's the end of the problem. That's also the end of the lesson. We have finished 19.1 completely, all the days. So go ahead and get started with your assignment. Have a nice day. See you next time.